What's poppin' pre-calculus? This is Tearing It Up, aka Mr. Tearin, rocking with you today, and today we're going to do 2.2. This is going to be split up into two different instructional videos. The first one, we're going to be talking about what's called leading term test, and then being able to look at turning points and factor. In the second video, we'll be looking more at leading term test and a vocabulary word called multiplicity, but we'll get that in the next video. So let's get after it here. So our objectives in this first video are to be able to graph polynomial functions. That's going to be really easy. We're actually not going to model any real life stuff. We've actually crossed that out of the curriculum. So just a few vocabulary words here. A polynomial function is just a function in the form of a polynomial, just something with a degree. A degree is your largest exponent. Your leading coefficient is the coefficient of your leading term. And in order to be a leading term, that needs to be the variable with the highest exponent. And turning points is just where the graph changes direction. Super easy. So I'm going to zip through these real quick. Being able to graph a transformation of a polynomial function. So, graph f of x equals x minus 3 to the 5th power. Honestly, you can just plug this into your calculator. I know that because it's something like an f to the x, the parent function is like an x to the 5th, and I know that it kind of looks more or less like that. I just know it's going to slide 3 units to the right. The important thing is here, when you're graphing, in order to receive full credit, make sure you at least have a few different points that are actually plotted on your line. Otherwise, you will not get full credit, okay? Moving on, again, you could just type this into your y equals and graph it. Just again, make sure you have a few different points on there so you get full credit. This is kind of the main idea of this lesson. It's called leading term test. If you would like to pause the video, you can go through and read through all these. This is a really good kind of representation of leading term test. Now just be careful when you read this. This is actually a plus sign. It's not tax. It's a plus sign. This is a negative sign here. This is a plus sign. And this is a negative sign. So what leading term test says is if I have a function and the leading term is positive and I have an even exponent, my end behavior will always look something like this. Okay, which means the limit as x approaches infinity, as x is approaching infinity, of my function is going up to positive infinity, and as x approaches negative infinity, it's also moving upward to positive infinity. That's where these statements are coming from. Okay, if I have a negative leading coefficient and an even first term, or an even degree of my leading term, then it's going to look like this. It's going to be upside down, and as x approaches infinity and negative infinity, f of x will approach negative infinity on both. Okay, so there's these statements that come up when you have a negative coefficient and an even degree. Next is when we have a positive leading coefficient and an odd degree for your first term. It's going to take somewhat of a shape like this, and your limit statements are right here. If you have a negative leading coefficient and an odd degree, then it's going to look something like this, and your limit statements are here. What this is essentially is it's just a fast way to describe the end behavior of a polynomial without necessarily having to enter it into your graphing calculator and graph it, which is super sweet because it saves a ton of time, and time is money. And if there's one thing y'all know about Mr. Tearin is he loves money. So let's keep rocking. So here we go. This is an algebraic kind of example. Apply leading term test so that you can explain the end behavior. So I don't even care about any of this. I'm just looking at this one right here. So I know right here, I know that the 3 is I know that the 3 is positive. So I have a positive leading coefficient, and my degree is even, so I have a positive even situation. And if you have your notes from before, a positive even is going to look something like this. That's positive even. So because it's positive and even, I know that the limit, let's go here, let's go blue. The limit of f of x as x approaches negative infinity, as x is approaching negative infinity, what's happening to my function? It's going up to positive infinity. And the limit of f of x as x approaches positive infinity will also be positive infinity because it's going right back up. Okay, so that's all leading term test is, just taking a look at your leading term and being able to describe end behavior from that. Look at another example here. Again, this is, well, I got to be careful here. I almost made a mistake. That is a very common mistake. Before I do leading term test here, notice this is not my leading term. It's just put there. If I were to rewrite this in standard form, it should be written like this. Okay, so make sure you don't goof up on that. So when I do this, now that it's in standard form, meaning the highest exponent is in the beginning. So now that it's in standard form, I'm really just looking at this term. It looks like my leading coefficient is positive, and it looks like my exponent is odd. So if you know, a positive odd looks something more or less like this. And so from that, I can say then, right here, I can say the limit as x approaches negative infinity, my function will approach negative infinity. And as my function approaches positive infinity, notice my function will approach positive infinity. That's all leading term test is. We're going to do one more quick example on something totally different. This is zeros and turning points. You could read all this if you want. Really, this is the important part is the number of possible real zeros will always be equal to the degree, and the number of turning points is always equal to the degree minus 1. So something like this. The easy part of this is state the number of possible real zeros and turning points, but then we want to go ahead and determine all the zeros by factoring. And I think the factoring, I mean, I know you've done a ton of it, but we're going to be doing a ton of it in this class, so you might as well get used to it. So possible number of zeros, I would say there are 3 possible because my exponent or my highest degree is a 3. And number of turning points is equal to 2 because it's just 3 minus 1. Now, though, I want to go into the factoring, which is the more fun part if you ask me. But then again, I am a math teacher. But here we go. So we have x to the third plus 5x squared plus 4x. So the first thing I want to do is I'm thinking to myself, well, I have a greatest common factor here. I can factor out an x out of everything, so I will do that first. So I'm left with x squared plus 5x plus 4. Notice now I have a trinomial here, a quadratic that I can factor. So it's just going to be x plus 4, x plus 1. All this is equal to 0. So now I can use zero product properties. So x is equal to 0, x plus 4 is equal to 0, and x plus 1 equals 0. So just x equals 0, x equals negative 4, and x equals negative 1. That's all there is to it. I think we're going to go ahead and stop there. This is just another practice question if you'd like to do it. But that's it for this video. Here's the solution if you'd like to get into that. I'm trying to keep these videos fairly short so you're not stuck all day doing this, but that's pretty much it for the first part of 2.2. If you have any questions, ask your teachers. They will be more than happy to get back to you. With that being said, have a nice rest of your day. Peace out, y'all.